In this video, we're going to be showing why the circle theorem that states angles in the same segment are equal is true. This means that two angles originating at different points on the circumference of a circle, as long as they are in the same segment, must have the same value. But before we get into why this statement must be true, we need to clarify what we mean by angles in the same segment. Now let's draw a chord between any 2 points on the circumference. Now the circle is divided into two segments. We have the top segment and the bottom segment. Let's take the upper segment of the two. Select any point on the circumference as long as the point is inside the segment, and then from each end of the chord which created the segment, draw a straight line to the point that is on the circumference. That results in an angle at the circumference where the two lines originating at the ends of the chords meet. This is an angle in the upper segment. If we take another point on the circumference within the same segment, and then again from each end of the chord that created the segment, we draw a straight line directly to the point on the circumference. This results in another angle at the circumference created by the two lines that originated at the chord that created the segment. The circle theorem is stating that these two angles must be the same. Whichever 2 points you choose on the circumference within this segment must always have the same value. So these two angles must have the same value. And that's what we're going to demonstrate in this video. A word of caution, you may see an example without the chord, but the rule still applies. So if you see a question involving angles in the same segment, you could just draw the line in and do your calculations. This is one of the easier circle theorems to prove. We can do it using another one of the circle theorems. I previously made a video proving this other theorem, that in a circle, the angle at the edge is half the angle at center. This is normally stated in another way. That is, the angle at center is double the angle at the edge, at the circumference. And we can actually use this theorem to prove that the angles in the same segment are equal. If you haven't seen how I proved that this angle is half this angle, I recommend going back to my video. It'll help you better understand today's lesson. I'm going to start by showing where the center of the circle is. And then, taking 2 points from the circumference, I will draw two separate lines from the circumference to the center of the circle. This creates an angle at the center of the circle and will give the angle a value of A. Now we're going to create another angle by choosing a point in the circumference and drawing two straight lines from that point, one to the end of each radius touching the circumference. This creates an angle at the circumference and give the angle the value B. Now, according to circle theorem, the angle at center is double the angle at the edge. And that means that A equals 2B. Now let's repeat this process for a different point on the circumference. We have the angle A. We can draw two straight lines, each going to the end of one radius touching the circumference. This creates another angle, so let's mark the angle, and this time we'll give the angle the label C. But the theorem that says the angle at center is double the angle at the edge applies here also. So A must be equal to 2C. Now let's put back in the first angle we created at the circumference. And we can see from our equation that A is equal to 2B and A is equal to 2C, which means that 2B and 2C must be the same value. So 2B equals 2C. We can divide both sides of this equation by 2, and that means that B must be equal to C. And now that we've shown that those two values are equal to each other, we can remove the A angle. But you should be able to see that the angle B and the angle C are two angles in the same segment. Let me help you by drawing the chord. So it's clear that these two angles are in the same segment, yet they have exactly the same value because B equals C. And that's exactly what we were looking for. We were looking to show that two angles in the same segment have exactly the same value.